Alright, welcome to another little video. This one is mainly about functions and relations, and we'll also talk about independent and dependent variables at the end. Thank you. Alright, let's start with the basics. The definition of a function is essentially each x has to have a unique y. So that's where my little story about Xenia, who is our x, starts. And Xenia is just a little x, and she's going swimmingly along, and she's with Yannick. And her and Yannick are getting along just fine. So when they are together, just one x and one y, they are, of course, functioning. However, when Yannick starts to get boring, and all of a sudden, Xenia has Yoshi added into the mix, now all of a sudden, we have this complicated, what I call, relationship. So this is my little story about how Xenia, the x value, and Yannick were dating fine, and they had a one-to-one relationship. They were functioning. However, Yannick got boring, added Yoshi in, and now they're in a relation. So this is a quick little story to help you remember that when things are going well, there's one x and one y, and when things seem to get messy and you have one x and more than at least two y's, heaven forbid we add in YOLO, as was discussed in class, scandal in the coordinate world. Alright, here's a typical graph of a straight line, and what we're looking for when we're trying to figure out if something is a function or a relation is the idea that if you pick any x value and you go up, you find, in this case, only one y value. If you put an x value here and you go down, you find one y value. So in this case, this graph clearly is a function. Alright, let's look at this graph. So again, we pick any x value here, and we go up, and we find a y value, and we go down. Oh my goodness, scandal, scandal. We now have a relation. Let's look at two lines. Now, if you notice here, these lines actually overlap a little bit right here. And so now we can ask ourselves, well, if we pick an x value here, and we go up, and we find one y value, and we go up again, and we find another value, what do we have? Well, if this is Xenia, this is Yannick, and this is Yoshi. So, based on our little model, we have a relation. Alright, let's have a look at this one. Notice on the red line there's dots. Have those as the included ones, and the lines without dots are sort of the open circles. So there we go. Alright, so now let's have a look and see what happens. If you have an x value here, and this one y value is included, so that's good. This y value here is not included. So this is sort of waiting in the wings. So here we have one y value for sure, and this one isn't exactly included, so this is still, you got it, a function. Let's look at the parabola. This is a graph you'll spend a lot of time in if you do pre-calc 11, and ask ourselves the same question. Well, if you pick an x value here and you go up, you find one y value. How about over here? You find one y value, and if we extended this a little bit higher, you find a y value. So, because we never hit the graph twice for a y value, this is a function. Alright, let's have a look at a circle. So as you may see by now, if we pick any x value here and go up, we find a y value. There's our y1. Scroll down, find a y2. So is this a function or a relation? Has to be a relation. Here's a piecewise function, so we might ask ourselves the same question. If we pick any x value and scroll up, we get 1y. How about over here? 1y, over here, 1y. You got it. This one's still a function. What do you think it is? Quick, before I tell you. You got it. Function. Alright, here's two special cases, the horizontal line and the vertical line. One of them is a function and one of them is not. Quick, which one is which? Well, if you pick the horizontal line as our function, you got it, and if you pick the vertical line as our relation, great job. Because essentially, for this x, how many y values are there? Yikes! Scandal! Infinitely many. So this is definitely a relation. Alright, here's another question. Broken graph, so we can pick the x value of 3 and see what happens. Well, this y value is included, this y value is not. We discussed that earlier in the video. So what is it? You got it. It's still a function. How do we make this graph a relation? Well, If we colored in this dot ever so carefully, now this would be a relation. All right, here's a complicated looking graph. Let's see if this is a function or relation. So let's see if for any x value, it has two or more y values. So minus 2 just has 1, minus 1 has 1, 1, 1, 1, none, and 1. So based on that, what do you think it is? Quick, function or relation? You got it. It's a function. If you said function, great job. All right, let's have a look at two tables. We'll call this one table A, and we'll call this table B. So the question is, which of these tables is a function? Now, what we're looking for, we use the same idea as we did in the previous ideas, is that every x has to have a unique y. So if we go back to Xenia and Yannick, essentially what we're looking for in a table is that Xenia is not cheating on any of their y counterparts. So let's check the first table. There's 1 and 3. Check down, there's no other 1s. So 1 is unique. 4 and 5, no other 4s. 3 and 7, no other 3s. 6 and 3, no other 3s. Now, notice for a moment, if you will, that there are 2 3s in the y section. The y's don't determine if it's a function or not. So all we're doing is checking for unique x's. So far, table A passes the function test. All right, let's check the other column, B. So 1 is with 3. Great. Oh no, 1 is with 5. Here we have a scandal. So this is Xenia with Yannick and Xenia with Yoshi. This does not meet the function requirements. So this must be, you've got it, a big fat relation. All right, let's have a look and see if we can tell if a set of coordinates is a function or not. So I have a red set and a blue set. So quickly, see if you can decide if red's a function or if blue's a function. Off you go. All right, now, so let's check. Let's see what we can figure out here. Well, there's a 3, a 5, a 7, and a 6. All x's are unique. So, looks good to me. I'm going to give the red one functions. All right, let's check the blue ones. You have 3 is with 4, 5 is with 6, 5 is with 8. Oh no, and 6 is with 7. So unfortunately, the blue is not a function, it's a relation. All right, let's talk about function notation. A lot of people ask me, well, what is function notation? Well, function notation is simply a new way of renaming our average function. So for all the time we've been working with equations, we just use y equals, y equals. Well, there's a different way. It's a little bit more specific and a little bit more useful, and we call it function notation. So if it's in the variable y equals 3x minus 4, we say it's the function f in brackets, and in the bracket is the type of variable we use in the question, in this case is x. So it's f of x equals 3x minus 4. This notation is great for a couple of things. One, we can feed our function. That's what I call it. Just like if we were using our dog analogy in class, you have a lot of dogs running around. They don't have names. You just call them dog, dog, dog. It's not very helpful. Now we can start getting more useful names by giving our function an actual name. So let's feed our function a 1. So if I put a 1 in for x, that means where the x was in our function, it also gets a 1. So 3 minus 4 is minus 1. All right, another way is to figure out if you have an output, what the input was. So let's say, for example, you have f of x equals 26. You want to ask yourself, what number could I put into the original function so that 26 comes out? Well, at just first glance, if I put 10 in, 3 times 10 is 30, minus 4 is 26. So therefore, f of 10 equals 26. Now I'm just going to move over here. And we always ask ourselves the question, what's the input? So what goes in? What did we feed our function? Well, we fed our function, in the last case, a 10, and out came a 26. So my joke is, you always know when you put something into your dog, something comes out. So this is our in, and that's our out. All right, let's have a look at this function. D equals 8t minus 12. This could be a function about distance and time, for example, a physics question. So instead of writing f of x, we can simply use the distance function. It's the value of time, and it's equal to 8t minus 12. So let's feed our function something. So we feed our function, let's say we feed it a 2. 2 seconds have elapsed. So you get 8 times 2 minus 12 is 16 minus 12, which is 4. So that's if we fed 2 in, we get 4 out. So we put our input and we put our output. This is what we fed the dog. This is what comes out of the dog. All right, let's say we don't know what went into the dog, but we know that 12 came out. So then we have to go back to our original function and say, well, 18 minus 12 equals 12. What would t be equal to? So in this case, t would be equal to 3. So if we put 3 into the function, we get 12 out, and we write that as a coordinate. Our input is 3, and our output is 12. All right, for the last one, for example, maybe this is a question about cost, the cost of apples. So the cost of apples is c is equal to 6a minus 4. So if we're going to write this in function notation, we can use c of a is equal to 6a minus 4. So that's our new equation in function notation. We've just changed c to c of a, and now we know it's in variable a, and we know this is our expression. And now we can ask ourselves, well, what if we want to buy 5 apples? So the cost of 5 apples would be 6 times 5 minus 4, which would be 30 minus 4, which is 26. So let's say the cost of 5 apples is 26 cents. So now we have our input. We've put 5 in, we fed the function 5, and 26 came out of the function. So let's ask ourselves the question, what would happen if we don't know how many apples we bought, but we know the cost was 14 cents? So then you have to ask yourself, well, what would go into that function? Well, 18 minus 4 is 14, so a would be equal to 3. So c of 3 equals 14, if I've done my math correctly. And if we write this as a coordinate, the input that went in was 3, and the output was 14. All right, the last piece of the puzzle. A lot of people ask, which one is the independent variable and which one is the dependent variable? Well, in this case, the independent variable is the part that you would write in, let's say we're writing this of f of x equals 3x minus 4. This part is the independent variable, and this whole thing turns into the dependent variable. So on this side of the function is your independent, and on this side is your dependent. So in this case here, t would be your independent, and your distance based on time would be your dependent. Remember, we talk about the fact that a range only exists if there is a domain. So this is the same idea, that distance can only exist when there is an input from time. So let's talk about the cost of our apples again. So the cost of apples, a, is our dependent variable. And what is the changing variable? A would be your independent. So easy way to look at it is this side is our independent variable, and the other side is our dependent variable. All right, thanks for watching our little video on functions and relation, independent variable and dependent variable. The end.